Welcome to 3 Minute Theory. Most of the time in the VLSI interview, I have asked about the CMOS power basics. In CMOS, basically they have a broadly three type of power dissipation: dynamic power, static power, and short circuit power. Dynamic power, basically it is involved in the charging and the discharging of the capacitor based on the input which we are giving into the input of the CMOS. Suppose in that picture, if you carefully observe, if we give 0, then obviously because of the VDD is directly connected with the output, so the capacitor will be charged, and either way when we apply the 1, the capacitor will discharge, and the P dynamic equation is involved with alpha C VDD square F. Maybe you know C VDD square and F properly, but here the alpha is a new term which is a switching activity. The switching activity actually the transition of the input signal 0 and 1. We actually observing that in any particular input, how much the input is transitioning from 0 to 1 or 1 to 0 in the particular time. We can observe it into the probabilistic method. The static power is actually consumed when the chip is quiescent or off. Here the dominant part is a leakage current, because when the chip is off, obviously there will be a drift current will flow, off current will flow, and which is actually the leakage current. The P static is basically a I leakage into VDD. I leakage, the current of leakage is coming from the different direction of the every NMOS or PMOS device. If you studied the semiconductor physics very well, then you know there will be a subthreshold leakage, there will be substrate leakage, junction leakage, gate oxide leakage, and the gate induced drain lowering. Those all are the leakage which will actually superimposed, and it can affect totally in the I leakage current. And lastly, the short circuit power, which like when both NMOS and PMOS is on, like when the NMOS and PMOS in the saturation region, there is a direct path in the VDD to ground. So we can say it as a crowbar current. Because of the crowbar current, that short circuit power can happen. I also give the proper picture, if I think you can understand very well. Power dissipation, the dynamic power is a mostly dominant, 60 to 70% power dissipation overally affected by the dynamic power. Static power nowadays, because of technology, node is shrinking, so 25 to 30% power can also be coming from there. And short circuit power is basically a 5 to 7%. So I faced this type of question in interviews. So thank you.